So welcome back to reviewing for the semester 2 final, and logs is on the final, and this is what a basic log looks like. If I were to tell you its equation, I would say like y equals log, and the base could be whatever. You could make it base 2, base 3, base 4, whatever, of x. And if you have an XY chart, you'll be able to find a few points that are on it. Let's do log base 2 of x and take just a second to find a few points on that. So if I'm going to try to find a point on this, the first point I would go for is if I put in x is 0. Do you remember that you can't have a 0 there? Do you remember that the base and the argument couldn't have zeros in them? So that particular spot where x is 0, also known as the y-intercept, is the asymptote. So if you do 0, that's the asymptote. See the green dotted line I made there? So 0 would be the asymptote. How about if I put in x is 1? Well, that's going to bring up, like, you got to remember a whole bunch of rules like how to solve logs in your head without the calculator. I know you'll have a calculator on the test, but my question is, you're supposed to just know if there's a 1 right there, that you've won the argument, and so you're going to get nothing, and it comes out to 0. Remember that dumb little saying I had? Won the argument, boop, put a 1 in the argument spot, then you get 0. Now, if you're like, yeah, I didn't remember that at all, then it's fine. You just have to know how to type in log base 2 of 1 on a calculator, and I know some of you do, and some of you don't know how to type that in. So this is the part where we should probably grab a calculator. And if you haven't got a calculator, come up and borrow one from me. So now we've got, I think, everybody with a calculator. So if we're going to type in log base 2 of 1, there's 2 ways to do it. Option A, if you hit the math key on your calculator, and then the alpha key, and then the math key, math, alpha, math. If yours just popped up with a box for the base and a box for the argument, you win. You've got the new software. It's super easy. But some of you did not get this when you typed math, alpha, math. You have the old software, and then you need to know that you'd type this in as log 1 over log 2. See, you just put this part, which is called the argument part, you'd put that part on top, and this part, which is the base, on the bottom. Okay? Now that also brings up an important point. Log base 2 had a base of 2. But this one, for the people that have to type it in this way, they have changed it to base 10, because remember, if you don't write the base of a log, then you're saying that the base is 10. Do you remember that? So many little things to remember about logs. So this log, where it doesn't say a base for the log, that means base 10. What I've found is that if there's ever any problems on the test where there's no base, it's critical for you to write in what the base is, because it'll be all about the base. All right. So I just changed this from base 2 to base 10. That's something you could be expected to do. It could be an ACT question. It could be a question next year in pre-calc. That was base 2. Now it's base 10. So if you know how to basically type it into the calculator on the old school calculators, you also know how to change it to base 10. And then the last little extension on that is that base could be anything. It doesn't have to be base 10. If it was about typing it in the calculator, we need it to be base 10 because the calculator only does base 10. But if I need it to be base 7, it could be base 7, and it still would be equal, because you're proportionally changing the top and the bottom the same amount, so the answer is still going to come out right. So that's called the change of base. We didn't talk about that very much. We did talk about it, though, because I know that there's kids in the room that have the old calculators. So you'd have to type them in this way. Whereas again, I'm implying there is no base by saying just log, because that's the button on the calculator, but actually it's base 10. Okay, so all of that was to figure out what happens when we stick a 1 in, and we're graphing this thing, and we stuck a 1 in, and when you stuck in a 1, you get 0, because log base 2 of 1 comes out to 0. All right. How about log base 2 of 2? Let's stick in 2 right here. So to be able to graph them, you actually have to know a lot of things about logs. Log base 2 of 2. Oh, I know that one. If the bases are the same, the answer is already there. And the answer will be whatever the power is on the argument. And since there's a 1 right there, I hope you were thinking, yeah, if the bases are the same, the answer is 1. So log base 2 of 2 is 1. There, I've got the asymptote and 2 points. Is that enough? No, you will for sure need 3 points because these are a curve. Okay, so we need 1 more point. Well, let's put in 3. And you'll quickly realize you don't like it, because log base 2 of 3 is not something that works nice. It's some weird decimal. It's going to be hard to graph. So don't use 3. Mr. Breen, what do you think we should use? 4. Because then, if I put a 4 right here, where the x was, log base 2 of 4 is 2. I put in a 4, and I'm getting 2. Cool. Now, in case you don't know why that is the case, because if that 4 was made into 2 squared, then the bases would be the same. You'll find out that so much of exponentials and logs is about bases being the same. It's a huge deal. So, look, I made the bases the same. Then the answer is the exponent. It used to be a 4. I put in a 2 squared instead. Okay. So there are some points. 1, 0 was right here. 2, 1, go over 2 and up 1. That seems believable. Over 4 and up 2, that seems believable. I think my graph was, believable. I got 3 points. I got the asymptote in there. All right. Here's another logs question that you totally have answered before. This is not new, but you may not remember it. Log base 2 of x equals 1/3. Do you remember how to solve that kind? And no, you can't just type that into the calculator, because think about it. How would you put an x in, and then you'd have equals 1/3? But copy this one down, and about half of you are going to remember how to solve this. I'd like you to talk to the kid next to you. Maybe the other kid knows if you don't. All right. So it's the circle of logs is what one kid said. I want to make sure you know that this is not an official math word. The official way to say this is you're going to rewrite the log as an exponential. But I think it's nice. I made up that term, the circle of logs, because you always go around, you go to the other side of the equation, and then you come back. So it makes sense to me. 2 to the 1/3 equals x. And that could be done on a calculator. So take a second and let's make sure you know how to do that. You might think, well, everybody knows how to do that. Some people are going to screw up the fraction part. Take a second. Type that in. 2 to the 1/3, it's a decimal. This is not one I would expect you to memorize, but with a calculator, of course, you can do it. Sam, what'd you get?
1.2599.
Anybody else get 1.259, blah, blah, blah? Okay, good. All right, awesome. Then you know how to do that kind. So that was the circle of logs. And here's the circle of logs backwards. 7 to the x equals 14. And you might be thinking, oh, it's 2. No, 7 squared is 49. It's not 2. So can you make the circle of logs go backwards and tell you what the log is? So if you're stuck, the first thing you just do is write the word log. And then it'll make you realize, well, I got to have a number next. And the next number you have is this little base right here. So then you got to be thinking, like, which of those is the base? Oh, yeah, that one's the base. And then you do the circle of logs. Kind of like the circle of life, except a little more mathy. All right. Please compare this log that you wrote to the kid next to you. Max, what'd you write? Log base 7, and the right word is of. Log base 7 of what? Log base 7 of 14 is the correct answer. And when I say it's the answer, it means I got x alone. X is solved. X is log base 7 of 14. And that one is not a nice number. Why? Because I can't get 14 to be 7 to a power. Nothing I can think of could work. So then you'd have to use a calculator to get that decimal. Or if it was a multiple choice question, it could just be, that's one of the things on the multiple choice list. Log base 7 of 14. Okay. All right. So if there's a most important thing, it's that. It's being able to do the circle of logs. There's a lot more to it. Do you remember combining logs? Write this one down. Log base 3 of 5 plus log base 3 of x equals log base 3 of 10. You got that copy, Jeff? Copy? Take a second. Copy. Okay. Aiden D, tell me what you got for this part. Or don't you know? It's okay either way.
It's like times or down.
Ooh, okay. Would you agree that it's log base 3 of something?
Yeah.
Okay. Then the only question is, do you have 5 plus x or 5 times x? If you had to commit right now, final answer, what do you think it is?
5 plus x.
It is 5 times x. You were close. You had a 50-50 chance. All right. And then the other side is already a single log base 3 of 10. And this brings up a good point. Do you remember that if these parts are the same, then this part must equal this part. 5x equals 10. So then what does x have to be? 2. That's it. All right. The next little thing about logs is that whenever you see ln, you're supposed to do something. Do you remember that? Do you know what to do, Annabelle? You would not do it on the calculator. I know it's actually possible to do it on the calculator, but if I threw a letter into it, it wouldn't be. Here, I'll make it have a letter. Instead of 4, let's put an A right there. Now you couldn't use a calculator. So there was a thing that I told you about LNs that you're supposed to remember. And that would be the thing that would save you if you remembered it. Does anybody remember? Ooh, there it is. Log base E. Good. So whenever I see ln, I write, for this part, log base E. And then the yellow part's still there, of E to the A. And now another little saying kicks in. If the bases are the same, the answer's already there. That comes up in 3 places. Bases being the same is a really big deal, okay? So if the bases are the same, which they are, the bases of the log and the base of the yellow part, they're both the same. The bases are the same. So the answer is A. It's just A. So all of this can be, all of this can be replaced with just an A. The answer is just A. And in math, a lot of your job is to just simplify things. And if you realize that all that could be replaced with an A, then you should, because it'll be way easier for the rest of the problem. Okay. So, what was the key there? ln means log base e. So, if I were you, I'd be writing down just some key things like that. Unless you already knew it. If you already knew that that meant log base e, awesome, don't write it down. But if you're trying to study for this final, you should be making yourself a sheet. There's now you and later you. Later you is going to be wanting to like do some last minute studying for your math final. One of those little things I'd write down is that ln means log base e. All right. So there's so much to logs. I want to actually break things up a little bit. So I'm going to pause here in the video, and then we'll come back to logs again at the end of the hour. So there's some terminology for logs that you have to know. Like you knew I was calling that spot the base and that spot the argument. You remember that part? Okay. So then if I go log base 3 of 9 equals 2, that's the base, that's the argument, but what's that? You might feel like, well, we never talked about that. We did, but it was very brief. Because you just need to know that when you rewrite this thing, it goes in the circle of logs, right? And that means 3 to the second equals 9. And now can you tell me what the 2 is? It's an exponent. So when they ask you what is a log, see, look. This log equals the 2, and the 2 is the exponent. So what is a log? It's an exponent. The first teacher that told me that, I was like, that's dumb. I don't like that. Because it's only when it's not written as a log, you know, like this. When you write it like that, it looks like an exponent, but it doesn't look like an exponent when it's over here. But it is a truth that a log is an exponent. Okay. Now that's different than when I make a log into an exponent. And again, you might be thinking, well, I'll just type it in the calculator. I can just type that in. No, you can't. The M screws it up. So you have to understand this because we're going to throw variables into it so you don't just type them all in the calculator. So if you know the answer to this, you should be able to just talk to that other kid. You don't have to explain it. Can you just tell me what is the answer? Talk to the kid next to you. Do you know? All right. The answer for this one is just M. The answer is M. And I have a saying that goes through and works multiple times in this unit. If the bases are the same, which they are. These 7s here, that's a base because it has a power on it. That's a base because it's in the base spot of a log. If the bases are the same, then the answer is already there. And it happens to be here in this kind. And if you want to know why, I'll show you. If I don't know what this equals, I can say it equals x. And then I can go and say, technically, this is a log that's in a power. It's not a log that starts with log. It doesn't start with a log. It just happens to have a log in it. So if I was going to write it as a log, it would be log base 7, because you start here. Then you go to the circle of logs of x, and then you continue the circle of logs, equals log base 7 of m. And I believe that we've talked about this. If that and that are equal, then this must equal that. So that's how you can prove that the answer is the m. The answer is whatever is right there. All right, now let's go through a few more like that where I give you a log base 2 of 8, and you're supposed to be able to just go, I can do that in my head. It's this. But how would you do it? I personally would do it by making this 8 into 2 to the third, and then you're supposed to know what the answer is. Log base 2 of 2 to the third. Say it. 3. 3. The answer's 3. Because it's the exponent here. If the bases are the same, the answer's already there. See how this is a base, and this is a base because it has a power on it. In the end, it seems like everything's a base then, so I get how the saying isn't perfect. All right, how about this one? Log base 3 of 9, but it's the 4th root of 9. All of a sudden it got that harder. Make the bases the same, and the answer will be the exponent. I know you don't have too much concentration left in you. Stay with me, we're only got like 2 more minutes. Couldn't that 9 be made into a 3? Well, you can't just say 3, but you could say 3 what? 3 squared. You could say this is 3 squared. I mean, 3 squared is 9. Then you could say, so it's log base 3 of 3 to a power. I'll give you a hint. It's either 3 to the 4 halves, like 4 over 2, or it's 3 to the 2 over 4. It's one of those two. Talk to the kid next to you. What do you think this power is? Because that's the answer. It is 2 over 4. It kind of goes in a counterintuitive order, and the way I would want you to remember it is I have said that the roots go on the bottom, just like in plants, and the bottom part of that fraction exponent is the root part. That's the root part right there. It's the 4th root. So then the 4 goes on the bottom. So it's 2/4. Would it also be okay to reduce that? Yes, in fact, you have to reduce it. 2/4 is 1/2. So the answer was 1/2 on that one. All right. Log base 3 of 5 minus log base 3 of x equals log base 3 of 4. Do you know that you're supposed to combine logs that have the same base and make them into one log? That was one of those fundamental rules of logs, is if you can ever combine them, you should. Kind of like if you can factor it, you should. On logs, if you can combine 2 logs that are of the same base, you should combine them into one log. It's log base 3, big surprise. But the question is, what do you do with the 5 and the x? Talk to that kid next to you. Ryan, what do you say? X times 5, 5 times x, x over 5, 5 over x. Okay, I'm going to call on Henry. What do you say? 5 over x is correct. Equals log base 3 of 4. And since these are the same, then this equals this. 5 over x equals 4. And then you can solve that. It's a little annoying because the x is in the wrong spot, but I can times both sides by x because this is clearing fractions. You were supposed to learn that on the top 20, that if you have a fraction, you should clear it. See, that clears it. And 5 equals 4x. And then I divide both sides by 4. And it'd be 5/4. Okay, moral of the story. You have to be able to put things like this together into one log. And in this case, if it's a minus, take this divided by that. Okay. All right. Let's start the Schoology quiz together. Very first question. We did talk about it literally 3 minutes, okay, maybe 8 minutes ago. Aiden, a log is a?
Which one?
Oh, sorry, Aiden D. A log is a, do you know that one?
An exponent?
Yes, it is. Okay, number 2. Victoria.
Log base 2,400
Of,
of 2,400.
and what's it equal?
1.
Yeah, if the bases are the same, the answer is whatever that power is, and a power is 1, so it's 1. All right, Sam, number 3. Just read me the question.
Log base 4 of 16 of x.
Wait,
X in the next exponent area.
log base 4 of 16x, like that?
No, just like exponent x.
Oh, with an exponent. Got it. So 16 to the power of x.
Yeah.
All right, got it. Now, if you're going to answer this one, you have to know how to make the bases the same. Max, can you shut the door back there, please? High school kids being high school kids. At 16 could be written as a 4. Miss Carr. 16 gets replaced with a 4, but can I just write that? Yes. And then you have to know that that 2 will get times by the x because, Wyatt, what do you think the final answer is?
2.
Close. 2x. That whole thing. 2x. I know it feels weird to have an answer with the variable in it, but get used to it. Pre-calc has answers that are variables all the time. Okay. That's number 3. Number 4. Let's see. Who haven't I tortured in a while? Asher.
Yeah.
What's number 4?
Log base x minus 6 of 64.
Wait, log base x minus 6, like that?
Yeah.
Of 64 equals? Thank you. Valeria, you know what to do? Yes, you do. X minus 6, parentheses, to the third, equals 64. And then right off the top 20, except, actually, this is more like the exponents unit. Put it to the 1/3 power on both sides. Does that one cause absolute values? No, it's only even roots. You did a root, but it was a third root. So it's only if that bottom number is even. So it's no absolute value, it's just x minus 6 equals, ooh, I know that one. It's the third root of 64 is 4, because 4 times 4 times 4 is 64. All right. So that was an intense one today. Finish this up. Our homeworks are worth 10 points nowadays, twice as much as they were earlier. We only have like 2 left. That's all I got for you for today.